Hello, everybody. Thank you for joining my Microteach project. I'm pretty excited that you joined this project. We are going to talk very amazing topics regarding the power generation, electrical power generation based on photovoltaic plants. And the topic is going to wrap it up with something very specific. So here is the topic that we are going to talk in detail during this training. So we are going to talk about the virtual center topology solution for utility scale photovoltaic plants. And let me say this. We are not going to talk about the photovoltaic systems for residential and industry. We are going to be focusing this training in photovoltaic service for utility scale, like a big and massive power plants. So let's start it. I hope you enjoyed the same way that I enjoyed to doing this. And if you have some questions, I'm more than happy to answer that question at the end of the training. You can use the model site or you can email me, and I'm more than happy to answer these questions. Okay, let's start it. Okay, this is me, and this is Oscar, Oscar Rozo. I'm an electrical engineer. Um, my career is very focused in electrical power system engineering. I have more than 10 years of professional work experience in the energy and industry sectors. And I am like, I have like a deep inside knowledge in design, installation, configuration, and commissioning of control and protection systems for high voltage substation, medium voltage substation, conventional power plants like gas or steam, and also non-conventional substation like PV, wind, and hydro. Okay, my current role, I work at Siemens. I am part of the Future Grid group and very specific as senior consultant engineer for PV systems. Okay, so what will be the training topics? I have like a five like main topics. The first like four topics are going to be very academic, very like conceptual. We are going to talk about the photovoltaic power plants, how they are, where they are, what is the capacity of the power plants, what are the elements that you are going to find in a photovoltaic power plant. Also, we are going to talk about an essential component, is a PV inverter. So this is the main main topic of the discussion here in the training. Also, we are going to talk about the type of inverters, topologies, um, and after we talk about these like academic topics, we are going to talk about the virtual central power station topology. It's essentially the main topic of this conversation or this training. So I hope you enjoy. I hope that I'm going to be like I'm going to avoid to talk about it super technical things, but in some cases I'm going to talk. I have to go and talk about this very technical topics. Okay, let's start. Okay, what is we are going to talk about the photovoltaic solar power plants. So after this, I'm going to say just PV solar power plants. This is a great picture of a PV power plant. So in this place, at this place is where solar energy is converted into the DC electricity through the photovoltaic effect. And the energy is transformed into alternate current, AC, so it can be delivered to the power grid. For people that maybe don't know, the power grid essentially is driving in AC current. Most of the grid is AC. We have some high voltage DC transmission lines, but essentially the system is alternate current. So let me talk about the components that you are going to find in a photovoltaic or PV power plant. So here I have mm, identified five like major elements that you or major components that you are going to find in a PV system. So number one, we have here the PV arrays. I'm going to talk about what is a PV array, but essentially this element is the main component of the PV system. The second here, number two, this is the inverter power station. As I told you before, here we're going to the inverter power station is where we have the inverter, the step-up transformer, and some kind of disconnectors or protection for electrical protection. Here in number three, we have the e-house. Is a shelter essentially, where we can find the medium voltage switchgear, low voltage switchgear for the system itself. Number four, this is the power transformer. It converts low voltage, a medium voltage to high voltage to deliver this to the grid. Here, the number five is the energy storage system. Most of the PV system around the world has an energy storage system, but the energy storage is not part of this training. We are going to mention maybe something about the energy storage, but essentially this is not the main topic of the training. Okay. So let me talk about in detail of the PV arrays. When we are talking about the PV arrays, I need to start talking about the cell. Okay. The cell. A PV solar cell is a semiconductor device that converts solar energy into the DC electricity through the photovoltaic effect. So the conversion of solar light into energy. This element is makes this possible. And we have also PV modules. What is a PV module? A PV module is a number of individual PV cells interconnected together in a sealed, waterproof like package. So we have the cell, we have the module, and we have the array. What is the array? Array is a number of individual PV modules wired in series and parallel to achieve the desired voltage and current. So we start from cell, we move to the module, and from the module to the PV array. So when we have the PV array, we are going to find one of the essential components for the PV system. And this is the inverter. The inverter, the electricity in a PV solar power plant is generated by the PV array is generated in a DC current. So this electricity has to be delivered to the utility. Most of the utilities are or work in alternated current, AC. So we need this component, the inverter, that essentially is an electrical equipment responsible for taking the direct current generated from the PV array and converting into the alternate current, so we can deliver it to the power grid. I don't know if you are familiar with these guys. I always, when I'm talking about inverter, I like to mention this brilliant guys in the history. So let me let me show these guys. So here we have Thomas Alva Edison and Nikola Tesla. Uh, I don't know if you remember the battle of the currents. So when I talk about inverter, I like to talk about the inverter is a problem solver. And those guys, they never like agree together. So Thomas Edison support the DC current, Nikola Tesla support the AC current. So the only thing that maybe they needed to agree together was the inverter. So I like to mention this. This is just a little bit history. Okay, so PV inverter. We have in this trend we have two different types of inverters. One here is the central inverter, and the other one is the string inverter. Central inverters central inverter units are physically much larger than string inverter. Use longer wires and convert more power per unit. So usually in the market, you are going to find the central inverter is rated at megawatts, usually from 1 megawatt to 5 megawatts. This is the pretty much the power rate that you're going to find in the market. And the string inverter is smaller than the central inverter, and each unit convert less amount of the power compared with the central inverter. In the market, you are going to find that the inverter rate, power rate is coming from maybe 5 kilowatts to 150 kilowatts. So central inverter. This is a very detailed picture of a 5 megawatts central inverter. And central inverter is a like very complex machine. A central inverter also has many subsystems. For example, it has like its own cooling system. So you're going to find here the air-to-air heat exchanger. You're going to have also usually some vendors provide a cooling system with water or different element just to clean the power electronics. And also the central inverter has its own AC circuit breaker here. It's electrical protection for the AC system, and also electrical protection for the DC inputs, usually fuses. So this is essentially the central inverter. It's a very complex machine. Everything is like a massive generator, static regenerator, and everything together in a compact case. The string inverter it has the same function, but if you can see here, the string inverter has less components. So, and also also in the market, you are going to see that the string inverter technology is moving to like a plug and play technology. You don't need like a lot of technical expertise compared with the central inverters to change some modes. For example, this is the cooling system of the string inverter based on fans. And it's very easy to install and remove if something happened with the fan. This technology has really good advantage that we are going to talk very soon. But essentially, the difference between the central inverter with compared with the string inverter is the capacity and also the technology itself and how many components it has. So, and